And welcome to another episode of Let's Learn Zig. So what are we doing today? Well, I'm going to teach functions in Zig. We're going to go over quite a few examples, just going from how to write a function to how to mutate things like passing in a variable that can be mutated to methods on structs, and we get into Comptime a little bit. And that stuff's pretty interesting, especially if you kind of want to see how generics can work in Zig. So yeah, I hope you guys are enjoying the series. Again, just trying to make episodes when I can. It's not very consistent in comparison with the game engine series, which I try to be more consistent with that, but hopefully over time things are being built up and you guys find it useful. One other note is I think starting last episode with Let's Learn Zig, I started using Zig 0.16, and the rest of the series until I guess Zig 0.17 comes out will be on Zig 0.16. So if you're watching this in the future, things might be outdated. I don't think so. I think this was pretty some basic stuff, but things could always change. So just an FYI, but yeah, want to keep these intros pretty short, so let's get into the code. Okay, now in the code, let's start off with how you write a function in Zig. So just like any other language, you're going to start with the keyword of function. So in this case, it's fn, then the name of the function, and you're going to do any parameters, and then the return type, and then you'll write your function body. So let's analyze this. So again, so you have your fn, which just says you're defining a function, the name, and then here we have two parameters, can be really anything, and then the return type. We'll have return a plus b, and now let's see how you call it. So we'll just do an std debug print, and let's first show how to just call it. So here we have a, let's just say 2 and 3. So it's just that simple. So you just call it like the function name, some braces, and then, or parentheses, and then the parameters or arguments. So just say 2 plus 3 equals, and then the value we get. If we run this, we get 2 plus 3. One quick note, if the return type isn't void, so it can be void like this, but if it isn't, you have to return it. So if we don't, we see here, if we just try and call it, we get an error, value of i32 is ignored. So if you intentionally, like let's say there's a side effect of the function or anything like that, you can do underscore equals, and this essentially just discards the return value. So now let's look at that void type. So if we have something like void, let's just say it's gonna be some sort of string, and we'll say greet. So we know it's gonna be void, so we're never returning anything from void functions. Hello. Do an exclamation point, and then the name. So now if we come down here, we can just call greet. Let's do world. And if we run that, we get hello world. So as expected, nothing too crazy. This isn't going to do anything because there's no return type. So it's kind of just useless, really. Okay, let's say you want to return more than one value and you know the kind of definition. So we have min max. So you're going to take a slice of, in this case, i32, so a slice of numbers, and return the min and the max. So it's the function is defined just like any other function. The return type is the struct. So this will loop over and find the min and max. So in this case, we have 1 through 9. So we expect the min to be 1, the max to be 9. So if we run that, there we go. Min 1, max 9. Exactly what we would expect. It's nothing too crazy here, but just wanted to show how a struct can just be a return type, just like an i32. Okay, so this one's a little bit more interesting, but instead of defining the struct as its own type, you can kind of have this anonymous struct without any names. So what is this? This is essentially like a tuple in other languages. So we see we can kind of unpack it right here, and we get Q and R. So it's just like i32, we can see the types, and then we can get Q and R. So if we run this, 17 divided by 5 equals 3 with a remainder of 2. But what does this look like if you actually try and return it? So let's say we have const res. We see it's a struct of i32, but how do you actually get the values? So if we look at TeleSense here, we get at 0 and at 1. So we can see you're kind of just grabbing in the 0 index and the 1 index from the struct that's returned. Okay, so now we're going to get into how to actually mutate variables. So in that first example of add, you couldn't actually mutate a variable, but I'm going to show you how to now. So there will be a whole episode dedicated to pointers, but if you don't know pointers, all you need to know is that it is a memory address and it points to a value in memory. So a pointer, like this is how you define a pointer. So it's a pointer to an i32. So the actual value that gets passed in here is a reference or the memory address of this variable 5. So, or n, sorry, the variable n. So the variable n resides somewhere in memory. And when you do this ampersand, you're saying, give me the address of where that is in memory. And we're passing that in here. So that memory address then points to the number 5 because we're storing 5 in the variable, and the variable is just a memory address. So now we can use the syntax of dot star to actually mutate, and then we're just adding 1. So let's actually add one more log so we can see n is something, and then n is now something else. So if we run that, n is 5, and then n is now 6. So we see we're using the same variable, but it's getting mutated. Okay, so now let's show errors. So error unions or error types is defined by putting this little exclamation point before the return type. So what this is saying is this function, parse positive, can return a U32, or it can return an error. So we can see it can be this must be positive error. But if you see this try right here, that means parse int also has an error union. So if we look, it has that exclamation point, and you can actually define the exact errors you'll see, or it returns a t. So we look overflow and invalid character. So it can be one of those two, or it can be error must be positive. So I hope that makes sense. And then how you actually call it is we'll do that same thing of unwrapping it. So if we get we'll try. So if an error happens, it's going to just like unwrap it and throw an error and kind of crash your program, or it'll just return the value. So in this case, 42, that is positive. So we see we get 42. But now if we look, remember we saw 0. So we say must be positive. So error, and we'll get the error must be positive. But remember how I said parseInt can also throw an error. So if you remember what one of those errors are, we can go into it, we can see invalid character. So that's one of them. And ASDF, those are invalid characters for an integer. So if we look, so go into parse positive all the way up into invalid character. And that's exactly what was thrown. So if you want to be as explicit as possible, remember the two errors that came from parseInt were invalid character and overflow. And then we are also having a must be positive. So if we want to be as explicit, like I said, we can say this function returns a parse error or a U32. And then we can also be a little bit more explicit with how we're returning it. And yeah, so this will be the exact same thing. That one will error, but it's going to work the same. If we go now to 32, it's going to say 32. So we actually have 3 options of how we want to call this function. So we already saw try, and this will, if it errors, just like propagate it up and like call it a day. But let's say we don't want to do that. So actually we can see here, it's going to say error or U32. Let's just say we always want to return 0 if it throws an error. So this is now you're not going to crash your program. It's going to run properly. So if we run it first, 32, that's expected. But now if we get ASDF, it's 0. And now remember how 0 would throw an error before because of this line. But now if it parses 0, it's going to return 0 because it's here. But now there's, like I said, there's one more way to actually handle this error, which I think is the cleanest. And if you're writing production software, so what you're going to want to do, you don't want errors to propagate up, but you also don't want to silently catch errors because you might not know what's happening. So you want to log it. You want to know what's happening, how it's happening, but then still return that nice, in this case, 0 or whatever kind of default value you want. So right now we're going to do this, which is kind of the special kind of Zig syntax for saying return in its own way. But now do error name. Okay, so what's happening here? So one, we're catching the error, but now we're catching the actual error value in this kind of closure. So between these pipes, and then we can print it. So this is this line, we're printing it, but we're also giving this kind of, this block, we're giving it a scope, and that's BLK. So that's essentially this, you're defining a scope, and now we can return a value. So now what's happening is if parse positive returns no error, we're going to return the value of parse positive. Otherwise, we're going to log the error. So we can see. So we logged it, but then we still return that 0. So it must be positive. Let's do invalid characters. I think one more can be like an overflow, because again, this will wrap around because we're parsing U32s. But then if we do a valid number, there we go, and that works. Okay, now let's get into kind of a more fun, little interesting example of how to pass functions as parameters. So we can see here we have this nice double function, which all it does is it takes a number and returns double it. But what we're going to do here is we're going to call apply twice. So we're going to double 5 twice. So we would expect the output of 20. So what does this look like? Well, one, this is a definition and then the value. So we can see 5, this is as normal, just passing a parameter 5. But now this is what the definition of a function looks like. So if we look, double matches the same function definition. So we see function, it takes a single I32 and it returns an I32. And what does double do? Well, it takes an I32 and returns an I32. So these definitions here and here have to match or else you'll get a compile error. So it's just like a normal type. If you try and pass a float as an int, that's going to throw a compile error. If you try and pass, let's say, a function that takes an I64, it's not the same type as an I32, so it's going to throw an error. And then one kind of note of why this needs to be a const pointer is that functions, you don't know the size at compile time, but you know the size of a pointer. A pointer will always be 64-bit if you're on a 64-bit machine, or 32-bit if you're on a 32-bit machine, but we know the size will always be 64 bits. So then compilers will know that, and then we know the size of the function, or the size of kind of what's being passed in. It's always just a pointer. So that's just a note of why it's const pointer. Okay, so now I'm going to give 2 Comptime examples, and then I'm going to show you how to do structs, and then that's going to be it. So let's get into this one. So one's going to be repeat and a value, so a character. So we're going to repeat a character 5 times. And what's interesting about this is Comptime. So I'll have another whole episode dedicated to Comptime, but to show, kind of just make it clear, Comptime, this gets executed when your code is being compiled, not when it's running, when it's being compiled. So that's why Comptime, it kind of has restrictions like this number 5, that's obviously known by the compiler at compile time. So if you're passing any value in it as is n, and that's marked Comptime, the compiler needs to know it before runtime. So if you're getting like, you're reading a file and then let's say the file has a number and then you're trying to use the number to repeat, that's not going to work because at compile time, you don't know what's in that file. It could be anything. So I hope that's clear. So what's this doing? So we're taking Comptime. Normally you can't have dynamic slices, but again, this isn't truly dynamic because it's going to be computed at compile time. So at runtime, you know the size of the slice. So in this case, it's 5. So again, let's run it. So let's see. Do we get 5 stars? Yes, we do. Or let's say you want to make it 20 question marks. Run that. There you go. There's 20 question marks. So now let's get into a slightly more interesting example. Okay, so now we're going to get into how you might see generics work in Zig. So let's say you want a function that you kind of just want to have any sort of int or any sort of float work, like this max function, for example. You want to be able to pass in any ints, floats. There's so many different types in Zig that they just have to have a comparison. So what does this look like? Well, at Comptime, you're saying you're defining this t, and then you're using elsewhere. So what does this look like in another language? Well, you may see something like this in other languages, where it's at, bt, and then you're turning t. So this is the exact same thing, but all it's doing is taking the type as the first parameter instead of being with the kind of angle brackets. So that's the only difference, is it's just everything's just a parameter. There's no special syntax. It's just using Comptime to do this. So as we can see here, I32, we're taking the max of 2 I32s, or an F64, we're taking the max of 2 F64s, which in this case, it should be 7 and 2.5. So let's run it, see what happens. Okay, so now let's actually try and run that. There we go, 7 and 2.5, as expected. So yeah, I hope this is clear, but it's just like generics in other languages, but you're just passing it as a parameter. Whatever type you want, it's just another parameter, which I think is very clear. Okay, our last example of the day, and that's going to be methods on structs. So what does this look like? So one, you're going to define a struct like normal. So yeah, so you define a struct. In this case, it's just going to be a count, going to be a counter. So it's going to have 2 methods. And one very important thing to right off the bat is we have pub. That means public. That means that the callers, like when you create it in another environment, you can actually call it. If this wasn't public, we wouldn't be able to actually call it. Okay, so now let's kind of get into increment. So you have a pointer, and remember what pointers mean in our earlier example? That means you can mutate it. So we wouldn't be able to do a plus equals 1 to mutate this value if this wasn't a pointer. So first of all, let's just see what the output is. So what are we doing? We're calling increment, increment, and then getting the value. So if we run it, we get a count of 2. So that makes sense. Start at 0, and then you increment it to 1, increment it to 2, and then you print the value. So yeah, so you're mutating the value if you pass a pointer. So now let's say value. What's this doing? Well, it's just grabbing the value. Again, it's not mutating it, so hence you don't need a pointer here. But if you also know counter is going to be a big object, you can do const pointer. And then we can see here, it's going to be the exact same thing. There won't be any differences, but you're just saying, hey, still take the memory address, but say like const means you cannot mutate it. So if we look here, so obviously we can't make const, we can't make cconst because of the increment function. See, it errors, yeah, because of increment, right? So that makes sense. But what if we just got rid of the increment calls? You see, like there's a pointer here, but this is const. So would it run? Yes, it does run because this is const. As soon as we get rid of that const, this no longer compiles because that same error. Kind of one other note I want to get at is the fact that this always has like counter. If you want to be a method that you can call like this or like this, it needs to be the type is first. So the type of the struct needs to be the first param, because what the compiler is doing is if we go over here, it's actually turning the c.value into counter.value, and then you're passing c as the first parameter. So these two things are equivalent, right? And again, this is, I guess, the difference to make it clear. If you're doing this now, you just don't pass the reference, you're passing a copy. So if we run this, see, 0 and 0, it's the same thing, but all it's doing is calling it differently. So let's actually see this as a better example. Let's keep this const pointer, or sorry, pointer const. Oh yeah, so we have to actually go back to passing that. So we're in this, there we go, we have 2 and 2, but now let's do counter.increment at c. So again, you're never actually going to call it like this, but I just want to be clear like what Zig's doing, because it's nothing fancy. It's still 2 and 2. That's exactly what we expect. I just really want to show how these things are equivalent. All it is like, it's sure it's a method on a struct. It's just a function call passing the struct as the first value. It's nothing special. It's nothing crazy, nothing, no magic happening. And that's what I just want to show here. These two things are equivalent. And I hope you enjoyed the video. I, again, think there's some pretty interesting examples. I tried to keep things as simple and lean as possible, but also trying to show as much as possible. So if there's anything you think I missed, please let me know, drop a comment. Or is there anything you really liked? Also, drop a comment. That'd be really helpful to know what you guys like or dislike. And yeah, and if you want to ever chat, the Discord link is always down in the description. Come say hi. Always enjoy chatting with you guys. So yeah, I mean, that's all I have. So just have a great day.